This is Algebra Lesson 4-7, Arithmetic Sequences. A sequence is an ordered list of numbers that often form a pattern. For example, you can have a sequence like 1, 3, 5, 7, in which there's 2 numbers between each number, so you go add 2 each time. Or there's other patterns that you can have as well. A term or the term of a sequence is each number in the sequence. So 3 is a term, 5 is a term, 7 is a term. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant, like the sequence above. If I go from 1 to 3, 1 to 3, we add 2. 3 to 5, you add 2. 5 to 7, you add 2. That's called your common difference, a fixed or constant number in an arithmetic sequence. The common difference in the sequence above is 2. A recursive formula is a function rule that relates each term of a sequence after the first to the ones before it. Okay, so in other words, if you didn't know how to write an explicit formula for the 1, 3, 5, 7, if you wanted to find the 15th term, you'd have to do the 14 preceding terms in front of it. That's a recursive formula. An explicit formula is a function rule that relates each term of a sequence to the term number, which means if I know the explicit formula of a sequence, I could find the 15th term without having to do anything with the preceding terms other than knowing the formula for the sequence. All right, when you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of the sequence. Oh, that's nice. Spelling error there. That should say term. All right, let's describe each pattern and let's find the next 2 numbers in the sequence. I have 1, then 5, and then 9. So we're going to start with 1, and to get to 5, we're going to add 4. From 5 to 9, we're going to add 4. So if this keeps up, 9 plus 4 is 13, and 13 plus 4 is 17. So to describe the pattern, we're going to start with 1, and add 4 consecutively, or add 4 repeatedly. You need to make sure you tell me the number you start with, because if you started with 3 and add 4, you're going to have a totally different sequence than if you started with 1 and then add 4. So you tell us the starting number. I'm going to start with 1, and then I'm going to add 4 repeatedly. Okay. A lot of people like to say, oh, you're just going to add 4 to the previous term. Well, then you have to know what the previous term is. So if you tell me what the beginning term is, then we know what the pattern is. Let's look at this second one here. 1, then 3, and then 9. Okay, so I'm looking at this going, okay, I'm going to add 2, and then I'm going to add 6. Ooh, that doesn't work very well, does it? So it's not an addition formula at all. You're like, well, that didn't work. So I can think of it this way. 1 times 3 is 3. 3 times 3 is 9. Aha! I believe they're multiplying. So 9 times 3 is 27. So that would be here. And then 27 times 3 is 81. That would be here. So our pattern is start with 1, and multiply by 3 repeatedly. So as you can see, the sequence in A is an arithmetic sequence because we constantly added 4 each time. The sequence in B is not an arithmetic sequence because we can't add the same number each time and get to the next term. Let's look at C. If I look at this, I'm like, ooh, I'm going to add 3, and then I'm going to add 5, and then I'm going to add 7. So you're like, ooh, you're adding consecutive odd numbers, but that doesn't really work. I mean, you can say you can add consecutive odd numbers. That's a perfectly good pattern. It would be really hard to figure out the pattern beyond this. And we're going to learn a little bit later in the lesson today what you do when you notice you're going to add consecutive odd numbers to a pattern. So then I'm going to have to add 9, right? If I add 9, 16 plus 9 is 25. And then I'm going to add 11, which makes it 36. So start with 1 and add consecutive odd numbers. So again, that is not an arithmetic sequence. Let's look at the next thing here. To identify if something is an arithmetic sequence. Tell whether each sequence is arithmetic. If it is, what is the common difference? Right, to figure out if it's an arithmetic sequence, you just simply see if it has a common difference. You see if you're going to add something or subtract something repeatedly, and the same something, like add 4, add 4, add 4, subtract 2, subtract 2, subtract 2. So if I look at this first sequence here, 7 to 11, I'm going to add 4. 11 to 16, I'm going to add 5. 16 to 22, I'm going to add 6. So we're not adding the same constant number each time. So this is not an arithmetic sequence. No common difference, not arithmetic. Let's look at letter B here. 3 to 9, that adds 6. 9 to 15, that adds 6. 15 to 21, that adds 6. So yes, this is, common difference is 6, so this is an arithmetic sequence. Okay. A sequence is a function whose domain is the natural numbers. Those are your counting numbers, 1, 2, 3, 4, 5. And whose outputs are terms of the sequence. You can write a sequence using a recursive formula. Recursive means it keeps recurring over and over and over again. Consider the sequence 7, 11, 15, and 19. You can use the common difference of the terms of the arithmetic sequence to write a recursive formula. Okay, for the sequence 7, 11, 15, 19, the common difference is 4. So if we let n equal the term number of the sequence, first term, second term, third term, and a of n is the value of the nth term of the sequence, okay, the value of the first term we know is 7. Okay, the value of term 2 is going to be the value of term 1 plus 4. Okay, so in that case, that was 7 plus 4, which is 11. The value of term 3 is going to be the value of term 2 plus 4, which would have been 11 plus 4, which is 15. The value of term 4 is the value of term 3 plus 4, which is 15 plus 4, which is 19. And the value of the term n. Okay, so term n would be, if you notice, your term is always one less than your term number. Term 2 is a of 1. Term 3 is a of 2, and term 4 is a of 3. So the nth term should be a of n minus 1, because we have to subtract 1, and then we have to add 4 to it. So that is the recursive formula. So the recursive formula for the sequence above is a of n minus 1 plus 4. So if you need to find the 25th term, you have to know what the 24th term is and add 4 to it, okay, which can be a little bit frustrating. Okay, so we're going to write a recursive formula. It says write the recursive formula for the arithmetic sequence 3, 9, 15, 21. What is the 9th term? Okay, so if I let n equal the term number, and I let a of n equal the value of the nth term, okay, so term 1, so a of 1 equals, well, that was 3, because it says so right there. 3. Term 2 is going to be a of 1 plus whatever we figure out that this common difference is. Well, from 3 to 9 is 6. From 9 to 15 is 6, and from 15 to 21 is 6. So we're going to have to add a of 1 plus 6, which is 3 plus 6, which is 9. The third term is going to be the second term plus 6, the value of the second term plus 6, so 9 plus 6, which is 15. the fourth term is the value of term 3 plus 6. Well, the value of term 3 was 15. 15 plus 6 is 21. That's how far we got with the actual sequence that we had above. Now we're going to continue going. Fifth term, because we have to figure out the value of the ninth term, and the only way to figure out the value of the ninth term with the recursive formula is to do the 8 terms in front of it. So that's going to be a of 4, plus 6, which is going to be 21 plus 6, which is 27. The sixth term is going to be a of 5 plus 6, which is 27 plus 6, which is 33. The seventh term is a of 6 plus 6, so the value of the sixth term, which is 33, plus 6, which is 39. The eighth term is the value of the seventh term plus 6, which means 39 plus 6, which is 45. And finally, the ninth term is going to be the value of the eighth term plus 6, which is going to be 45 plus 6, which is 51. So to find the ninth term, you must extend the pattern. Let's write our recursive formula. Our recursive formula says a of n equals a to the n minus 1, because you always do that. It's always going to be a to the parentheses n minus 1, the value of the term in front of it, and in this case, plus 6. So there's our formula. And the ninth term, so a of 9 here, was a of 8 plus 6, which we found to be 51. So you can clearly see that writing a recursive formula is easy, but using the recursive formula to find a number that's fairly far out there is rather difficult. You have to go pretty far with your extension, and it may take you quite a while to do that. To find a specific term using a recursive formula, you have to continue to extend the pattern. I just said that. You can find the value of any term of an arithmetic sequence using a recursive formula, but it's probably not the fastest way. An explicit formula will allow you to find any value of a term without having to do the preceding values. And it's found by using the following formula. The nth term of an arithmetic sequence with the first term, a of 1, and a common difference of d is given by a of n, which means whatever term number you're looking for, is equal to a of 1, the first term, plus n minus 1 times d. So let's take a look at that. An arithmetic sequence is represented by the recursive formula a of n equals a parentheses n minus 1 plus 15. If the first term of the sequence is 42, write the explicit formula. Well, the explicit formula says that we should have, if the first term is 42, and we're going to follow this formula right here, so, or actually this formula right up here, because this is a recursive formula. We want the explicit formula. What I've underlined double underlined here in green, that's your recursive formula. We're going to write the explicit formula. The explicit formula says take a of n, and that's going to equal my first term. Well, my first term is 42, plus parentheses n minus 1 times the common difference. And the common difference, we already know, has to be this right there, because that's what tells us, that's what we're given in the recursive formula, so that helps us with the explicit formula. So it's n times 1 times 15. So there's our explicit formula. You should be able to go vice versa, write an explicit from a recursive and write a recursive from an explicit. Let's take a look at this next problem. An arithmetic sequence is represented by the explicit formula a of n equals 8 plus n minus 1 times 11. What is the recursive formula? So the recursive formula is going to be a of n equals a to the n minus 1, because all recursive formulas start that way. And then we're going to add our common difference, which happens to be right there. So there's our common difference. A of n equals n minus 1 plus 11. And you say, so what? We've got all these formulas. What are they good for? Well, let's take a look at this. If you know how to write an explicit formula for something, you can find the value of something without having to go through the previous values. For example, a subway pass has a starting value of $100. After one ride, the value of the pass is $98.25. After 2 rides, it's $96.50. After 3 rides, it's $94.75. Write a rule to represent the remaining value of the card as an arithmetic sequence. What is the value of the pass after 15 rides? So if I look at this, if I go from 100 to 98.25, that's a common difference of $1.75. So that's my common difference. Okay, so to write my formula, I'm going to write it as a explicit formula because then I don't have to find 14 rides in front of it to find the 15th ride. Okay, so A of n is going to equal, my first term was 100 because it says you're supposed to do A of 1, which is your first term. Okay, and then you're supposed to add or subtract. Right? In this case, since it's going down by a common difference is actually negative 175. So we can add, okay, the n minus 1 times negative 1.75 because we're going down in value rather than up in value. So there is my explicit formula. So now I have to find the value of the pass after 15 rides. So after 15 means the 16th ride. So we're trying to find A of 16. So A of 16 will equal 100 plus 16 minus 1 times negative 1.75. Okay, so that's going to be 100. 16 minus 1 is 15 times negative 1.75. Okay. So if I take 15 and I multiply it by negative 1.75, I will get negative 26.25. So this will be 100 minus 26.25 because plus a negative is same as minus. So the value of my pass after 15 rides is going to be $73.75. And notice we didn't have to do the preceding 14 numbers to figure out the 15th number or the 15 numbers to figure out the 16th number. That's why I prefer a explicit formula. All right. Closure question. Describe 2 ways that you can determine the 50th term in an arithmetic sequence given the first term and the common difference. Should not be too difficult for you because we just talked about this.